So let's discuss all the question from DPP 1. Topic is properties of fluid, part 1 and part 2, whatever we have discussed in the last class. So the first question is, fluid is a substance that that we have option cannot be subjected to shear force, always expand until it's filled in any container, has the same shear stress at point regardless of its motion, cannot remain at rest under action of shear force. Now, if you know, in the starting class itself, I have told you that whenever you apply a shear force, whenever you apply a shear stress, definitely there will be deformation in the fluid. So the last statement, if you find cannot remain at rest, is definitely perfect answer for this question. I hope it is clear to all of you. Next question is, the ratio of dynamic viscosity to the density of fluid is known as. Now, dynamic viscosity is something which you have not studied till now. So, I'm writing for all of you for this question only, that kinematic viscosity is equal to dynamic viscosity divided by density. So kinematic viscosity is nothing but the dynamic viscosity divided by density. So in that case, your right answer will be nothing but the kinematic viscosity. This part you have not studied till now. In the next lecture, you will study this part. Next question. The property by virtue of which liquid opposes relative motion between its different layer is called. Now, so again, this question is also from viscosity part, which you have not studied till now. So the right answer will be viscosity. In detail, we will discuss when we'll discuss this in our classroom. We'll discuss this part in detail. Next question is again a very simple question for all of you. Anderson number can be defined as, it's a direct answer for all of you. You have already studied this part. That is K equal to mean free path divided by characteristic length of flow. First class, first discussion. Next. So it is necessary to mention that temperature at which a specific gravity is calculated because you now understand when we are giving a definition for a specific gravity, what is that? It's the ratio of density of any substance divided by density of reference substance. So when you talk about density, you know that density changes with temperature. So in that case, specific gravity for any substance will be always given for a temperature value. So now whatever option you find it right, you can choose it. C option, if you see, density of the substance changes with the temperature. That's what we are talking about right now. So C option will be the correct option for this question. Next question. So they are asking what is the specific gravity of a substance with mass 10 kg and volume 2 meter cube with respect to with respect to the reference density. It is 50 kg bacha. It's a typing error. It's a 50 kg per meter cube. Now you all know that finding a specific gravity is not difficult for you guys. Density of any substance divided by density of reference substance. So this we have 10 kg divided by 2 divided by 50 kg. So it will be 5 by 50. It will be 0.1. Not kg, only 0.1. So 5 by 50, it will be 0.1. Option A will be the right answer for this question. Is that clear? Coming to the next question, question number 7. Let me read this question for all of you. Mass of a substance is changing with respect to its volume as m equal to. So let us see, we have volume m equal to minus v cube plus 3v square plus, minus 2v. Minus 2v, if I am not wrong. Minus 2v. What is the maximum specific gravity of a substance between v equal to 1 meter cube and v equal to 2 meter cube? That's what they are asking. Density of reference substance is also given to you. So let us find out density first. So density is equal to mass by volume. So it will be minus V square plus 3V minus 2. Is that clear? Now if you find out specific gravity is what? Density of that substance divided by the reference substance density, that is 0.25. So it actually becomes 4D. So D we have minus V square plus 3V minus 2. But what they're asking you is the maximum specific gravity. To find out that maximum condition, simple maxima minima condition. What is that maxima minima condition? So for maxima value, differentiation of specific gravity, I'm writing in a short form, writing only S. So ds upon dv should be 0. So this will be minus v square, differentiation of minus v square will be nothing but minus 2v plus 3 equal to 0. So it will be nothing but 3 equal to 2v. So v equal to 1.5 meter cube. So this is the condition of volume in which the specific gravity will be maximum. And this comes in a range of 1 to 2 also. So that is also right, which is given in this question, that volume will be in 1 meter cube to 2 meter cube. So it is in between range also. So no worry. Now we find out the specific gravity at volume 1.5 meter cube. That's it. So we have 4. In place of volume, we have 1.5 square plus 3 into 1.5 minus 2. Okay. So let me give the value to all of you. If you calculate it, I have the calculator with me. So 4 bracket, we have minus 1.5 square plus 4.5 minus 2. If you calculate, we are getting 1. So specific gravity 1 we are getting. According to that, our right answer will be option A. And I hope it is clear to all of you. Question number 8. What is the mass flow rate of a liquid flowing through a pipe of which 100 grams of water was collected in 10 seconds? Okay. So they are asking mass flow rate. That means they are asking m dot. Okay. What they are telling, that 100 gram of water was collected in 10 seconds. So mass flow rate is mass, that is 100 divided by 10 seconds. They have given the value in kg. So we'll convert this gram into 10 to power minus 3. So it will be how much? It will be 10 to the power minus 2 kg per second. So 0.01, that means option A will be the right option for all of you. Okay. Going for the next question. A solid of density D is dropped in a liquid of density D. If D is greater than D, then Option we have solid with a partially sink. This part we have not studied yet. So right now for this, right answer will be option A. But this part we have not studied, so we will not discuss this part. We'll discuss when we'll discuss this part in class. After that, we will discuss. But for the time being, you also, like, this part we have not discussed till now. But for this question, as you all know that you have seen in example also, like in a water, anything which having density more than water will sink, na. Same thing, same concept I am using here. But this part I will discuss it again when I will be discussing about flotation buoyancy. I will discuss this question again. So for those guys who are not knowing this part, no worry. This part I will discuss it again. Right now, for example, you can see like in water, things which are having density more than water will sink. So in that case, solid will completely sink. That is the right answer for this question. Coming to the next question, that is the last question for all of you. Question number 10. What is the density of a liquid of a mass 10 kg and the contained in a cylinder of radius 5 meter and the surface area excluding top and bottom of 10 pi meter square? It's a simple question. Basic is nothing but they are asking you the density and it will be mass divided by volume. So contained in a cylinder, so cylinder will be like this only. Find out the volume of the cylinder. So it will be rho equal to 10 kg divided by volume is nothing but they have already given the surface area is 10 pi meter square. So surface area is 10 pi. And the radius is 5. So both are different thing. Don't worry. Both are different thing. So they have given the surface area and they have already given the see, if they have given surface area, if this is 10 pi, surface area of this cylinder is nothing but 2 pi r into length L. So r is given as 5 meter. So 2 into pi into r is given as 5 meter. Length we can find out. So length will be 1. Now finding volume will not be problem for you. For volume will be what? Pi r square. R we have 5 ka square into h. Length already we have find out 1. So density will be 10 divided by 25 pi. So if you calculate how much we are getting, somewhere around 5, 2 and then 5, 5, 2 by 5. So 0.4 approximately. 0.4. Roughly you will get 0.4. So 0.4 divided by pi kg per meter cube. Okay. So this is the value what we are getting. 0.4 divided by pi we are getting as a density. Because they are asking you the density. So density is equal to mass by volume. Mass we have already 10 kg. Volume we have find out pi r square h. That is cylinder volume. So pi is nothing but the same only. R we have given radius of cylinder is 5 meter cubes, 5 square into h we have calculated here the length part. This is nothing but the 1 meter. So I have multiply h 1 meter and now 10 divided by 25 pi. So I have cancelled that out and we are getting 2 by 5 pi. So it will be 0.4 divided by pi. I hope it is clear to all of you. I hope it is clear to all of you.